by the emission of very large quantities of sulfur dioxide into the atmosphere.
But back in his lab, it becomes clear to John Westgate that the composition of the Laki ash is just not what he's looking for. As the search continues, John slowly begins to see a pattern. The ash gets thicker and thicker around Southeast Asia. This region has over 70 volcanoes. But there is one so violent it stands head and shoulders above the rest. This volcano has erupted 7 times in the last 9,000 years, and even created one of the most violent eruptions of the 20th century.
3 reasons why we looked at Pinatubo. One is it was located in the right area. 2, it's capable of explosive volcanic eruptions. And 3, the overall composition of its volcanic ash is very similar.
Pinatubo blew its top in 1991 and subjected the surrounding area to an enormous 15 million ton cloud of superheated ash and gas. Hundreds of people lost their lives and thousands were made homeless. John immediately put Pinatubo under the microscope. During the hours of preparation, John was hopeful. Pinatubo had near-perfect amounts of silica content when compared with the mystery ash. But when he did the analysis, John's hopes were dashed.
When we started to look at the samples in detail, making those comparisons, we found that in detail they clearly are different. So we had to look elsewhere.
Days turned into months. Months into years as John discounted volcano after volcano. Volcanologists continued to send new ash and lava samples to the lab, but to no avail. It looked like this was one mystery not even John Westgate could solve. Then, in the spring of 1994, John arrived at work to find yet another sample. The very sample Craig Chesner had sent John all the way from Lake Toba in Southeast Asia to try and solve his own geological puzzle. John then put Craig's sample under the microscope, and things began to fall into place.
Once we had looked at the samples from Toba, lo and behold, it was exactly the same.
The Lake Toba sample matched up perfectly to John's mystery ash. It had the same high amounts of silica, and it too was 75,000 years old. This was the first time in 6 years John had come across a known sample and a known location that matched so precisely with the mystery ash. It is now clear that Lake Toba lies at the center of a pattern of ash distribution across half the globe. This ash is all 75,000 years old, a date linking it to a moment in the Earth's history when the planet's temperature plummeted and the atmosphere became choked in up to 4,400 megatons of sulfate. There's just one problem. Where's the volcano?
Let's climb up here and take a look at this rock. Yeah, I see quartz crystals, I see biotite, and there's ash in here. This rock was definitely generated in a magma chamber, but look at the incredible extent of this. It extends all the way up to the top of the cliff face here, and this represents a tremendous amount of magma. And the really strange thing is this is thousands of times greater than you find at typical volcanoes.
So what could possibly have put this much rock here? There's only one thing big enough to create this much rock in an underground lake of magma. And it's one of the most recent discoveries in volcanology. Supervolcanoes. To qualify, a volcano must produce at least 1,000 cubic kilometers of magma in a single eruption. It takes the Mississippi River 2 years to dump the same volume of water into the Gulf of Mexico. A supervolcano can put as much ash and rock into the air in just a few days. These monster volcanoes dwarf even the greatest eruptions of the 20th century.
When you see the footage of Mount St. Helens, it looks like a really awesome eruption. Big, tall ash column. It looks like there's tremendous power there. But that eruption only erupted 1 cubic kilometer of magma. So, as you can see, that's very much smaller than any supervolcano eruption.
Underneath Lake Toba, superheated magma seeped between 2 of the Earth's plates and began to melt the rock above.
We think that it might have taken 1 million years to accumulate all the magma that was beneath Toba.
Magma built up layer upon layer and created a massive magma chamber. The stage was set for an event of unimaginable scale.
I've collected rocks from around Lake Toba for many years. I've also studied ash samples that were deposited around the entire Indian Ocean basin. Although these ashes seem similar to the rocks around Lake Toba, it almost seems impossible that they could have actually come from this area. But when one considers the great size of Lake Toba, its depth, the tremendous relief around the shores, only one conclusion can be drawn. There was a supervolcano eruption here at Lake Toba 75,000 years ago. This eruption created this crater, this enormous crater that we're sitting in. This island here actually slid down off the walls of the crater during the eruption. Now we know that Lake Toba is the site of one of the largest volcanic eruptions ever to occur on Earth.
The evidence has provided Craig with his solution. But where has the supervolcano disappeared to? You're looking at it. Lake Toba is the massive fingerprint this volcano left behind. And the water you see today is just thousands of years of rain.